All right, so we are going to take a look at how a graham cracker gets digested in our body. We haven't learned any of the names of the digestive organs yet or what they do, so this will be an exploratory kind of activity. So the first thing we're going to do is we're going to look at the food molecules that are in a graham cracker, okay? And we're going to answer the questions here. So which molecule is found in the largest amount? That would be which one has the largest bar here. And as you can see, it's other complex carbohydrates, okay? Second largest, and then answering a couple questions there. Here is where the beginning of the little bit of a tricky part comes in. So we're going to examine some data on the next couple of slides. And the light colored bars show the amount of the molecule in the previous location. What do I mean about light colored bars? If you take a look here, we've got light green. Okay, so light green talks about where it was before, and the dark green is where it is now. And we're looking at how does it change. So again, we're looking at the amount of, for this example, water in a graham cracker. And this is in the original graham cracker compared to when it's in the mouth. So the idea here is if there was less water, then water would be taken out in the mouth. The mouth would be doing something to take out that water. Let me give you another example. If we go down further here, let's take a look at protein. Here we can see that light green is esophagus, that comes before, the dark green, which is the stomach. So between the esophagus and the stomach, the amount of protein decreases, which means it's getting digested. So let's walk through how to fill out this chart. So what we need to do is we need to put increases, decreases, or stays the same in this chart. Now, you can either copy and paste these little symbols like the arrows, or you can just write increases, or you could put an I for increase, a D for decrease, S for stays the same. So if we take a look here, you'll notice that my water, the two bars are the same. So I'm going to go ahead and I'm going to put an equal sign. The amino acids here, they're both 0. I'm going to put an equal sign. Proteins, again, another equal sign. Fatty acids, equal sign. Fat, equal sign. And here's where the trickier part comes in. So looking at glucose, my light green to my dark green, my glucose is increasing. So the amount of glucose in that food is increased. So I'm just going to copy and paste that arrow, or you could just write I for increase. And my complex carbs are decreasing. Okay, so light green to dark green, they're decreasing. My fiber is staying the same. So what does this tell me? Okay, why might my complex carbohydrates be decreasing and my glucose increasing? Well, these molecules, I'm going to skip down a little bit, but if you take a look, this is a complex carbohydrate and my sugar. So when my complex carbs decrease, they're being broken down to create more sugars. That's why my sugars increase. So you're going to continue filling out. We're going to go through the mouth, the esophagus, the stomach, the small intestine, and the large intestine. The whole idea here is that if our numbers are changing, stuff is being digested there. Okay? If they're staying the same, like my fiber doesn't get digested in my small intestine. So we're looking at where things get digested. And then we have a few questions at the end that you'll be able to use these pictures, these images for.